Today we are going to discuss about the first fit, best fit and worst fit allocation strategies with the examples. Okay. So here we have the memory partition. First example is consider 6 memory partitions with the sizes 150 KB, 350 KB, 600 KB, 250 KB and 450 KB, 300 KB. These are the memory blocks are available or free memory blocks. That is called the memory partitions. Then four processes we need to allocate to this corresponding memory locations. The processes are P1, P2, P3, P4 with the sizes 372, 225, 179, 409 KB. Okay. So here we need to apply first fit algorithm and best fit algorithm to allocate these processes, these four processes into the memory partition. Here we have 6 memory partitions. Within these partitions, we need to allocate four processes. Okay, so the first one is first fit algorithm. The first fit algorithm or allocation strategy, that means the processes to the first partition. That means the process which allocates to the first partition that is large enough to hold that particular process. Okay, so whenever a process found a space or first space or first partition or a memory block which is enough to store that a particular process, which is the size is enough to store that process, the block or memory that will be allocated to particular process. That is first fit algorithm. The entire memory block could not search in this allocation strategy. Only the first location that is enough to store that particular process, it will be allocated. So here from this example, P1 contain 372 KB or P1 size is 372 KB, 372 KB. So which we need to allocate particular memory block. Here one table is representing first column is memory block. This is the size which is given that 150 KB, 350 KB, 600 KB, etc. Okay. So 6 memory blocks are available. Then the next column which is available means these memory blocks are free or available to store any process. Okay. Then the next column which represent can occupy P1. We need to allocate P1 process. So here each memory block we need to the first block onwards we need to compare which is enough to store P1. Then that block corresponding block will be allocated P1. Okay, so for that can occupy P1. Here the first block is 150 KB, which is not the size that will be affordable to store P1. So here, so then we need to change the second memory block, that is 350 KB. Our P1 process which is size is 372. So this second block not enough to store that process P1. So here the third block which we need to compare, 600 KB is the third block memory partition size. It can't it is it will check with the P1 size, so it is enough to store 372 KB. Okay, so here the can occupy column we wrote yes, is it? Then we need to find out the remaining memory wastage. When we allocate process P1 among 600 KB, what will be the remaining memory wastage? We need to calculate it by 600 minus 372. It is equal to 228. So after allocating P1, 228 memory blocks inside the 600 KB, it will be wastage. So here the first block, it will be found, or it found that the P1 could the space enough to store the particular process P1. So here block 3 is the first fit to P1. So here P1 will be allocated inside block 3. Okay, so P1 is allocated. The next is P2. We need to allocate based on first fit allocation strategy. Here 150 KB is available. So it will be checked. From starting onwards, we need to compare. Okay, 150 KB, it is enough to store. It will check, is this enough to store P2, but the size is less than 225 KB. So that block is again free. 350 KB, the next space is 350 KB. So it will check with the P2 process size. It is enough to store the process P2. So here we need to allocate, or it can occupy P2. So the can occupy column P2, we wrote S in the memory block corresponding 350 KB memory block. Okay. Then we need to find out 350 minus 225 after allocating P2, whatever the remaining memory wastage is. So equal to 125. Is it? So here the block 2 is the first fit of process P2. So P2 is allocated inside the block 2. Here, after allocating P2, already P1 allocated in 600 KB size, then 350 KB is allocated to P2. Okay, so then P3 process, that is size with the 179 KB. So from the starting onwards, we need to check 150 KB is the first memory block. It is not enough to store P3. So the next block, that is 350 KB is already allocated P2, 600 KB is already allocated P1, then the free block is available 250 KB only. Okay, so the fourth block 250 KB, it is enough to store P3 process because size of P3 is 179 KB. So here we can occupy P3. So we wrote S inside that third column. Then we find out the remaining memory wastage, 250 minus 179 equal to 71. Okay, so here this is the block 4 is the first fit to P3. So we inserted, or we allocated P3 inside the 250 KB. Okay. So the next process is P4. Here the 150 KB, the first block is again free. So we need to check with the P4 size, which is enough to store P4 process. No, the memory block size is less than P4 size. Okay, so it is remain to free. Then the next block 2 is already allocated. Next block 3 is already allocated. Block 4 is already allocated. Then the next block 450 KB, that is block 5. Okay, so here we need to compare with the P4 process. So 409 is the size of P4. Then we allocated block 5, inside the block 5 the P4 process. Okay, so here we wrote can occupy P4 column, we wrote S. Then we need to find out the remaining memory wastage. 450 minus 409 equal to 41. Okay, so here we need to occupy the process P4. Block 5 is the first fit to P4. So P4 allocated to block 5. So after the first fit allocation, this is the memory strategy, or the allocation of processes P1, P2, P3, P4 in corresponding location. P2 is in block 2, P1 is in block 3, P3 is in block 4, P4 is in block 5. This is the first fit allocation. Okay. The next is best fit allocation strategy. Here, the process which allocates whatever the smallest partition that is large enough to hold the process. This means that each and every block of memory we compare with the process size, where then we need to find out which location or which memory block that is enough to store that particular process. Then we need to find out the memory wastage after the process calculation. Okay, so from this memory wastage, which location it contain the least memory wastage, that location could be selected as the best allocation or best location or best memory block to store that corresponding process. So each location or every location or every memory block, it will be compare with the process size. If it is matched with the process size, each location it will find out the memory wastage. The least memory wastage is the best location we need to allocate that particular process. Okay, so here we need to find out we need to allocate the P1 process, which is the same size 372 in case of best fit allocation strategy. For this, the same table with the memory block of 6 block, then we need to check can occupy P1. Okay, 150 KB is not enough to store P1 process. Then we need to check second block 350 KB. It is not enough to store P1 process. So the next space 600 KB, it is enough to store P1 process. So here we need to find out the memory wastage. 600 minus 372 equal to 228. Again, the next location we need to check 250 KB. It is not enough to store P1. Then the next block is 450 KB. It is enough to store P1 process. So here we need to find out the memory wastage. 450 minus 372 equal to 78. The next block is 300 KB. It is not enough to store P1 process. So here, when tried to allocate P1 process, we found two memory wastages. One is 228 and another one is 78. So 78 is the least memory wastage. So it will be selected as the best location or best memory location which is which is able to store P1 process. So here we need to store P1, that is the block 5 results in the least memory wastage. So P1 allocate to block 5. So here for the P2 process, it is size with the 225 KB. So again we need to check with the starting block onwards. Okay, 150 KB, it is not enough. 350 KB is enough. Okay, so we need to find out the memory wastage. 350 minus 225 equal to 125. Then the next block 600 KB, it is enough to store P2. So here 600 minus 225 equal to 375. Then the next block is 250 KB. It is also enough to store P2 process. So here we need to calculate 250 minus 225 equal to 25. Then the next location, it is already allocated P1, so it is not free. Okay, then the 300 KB, it is also enough to store P2, so we need to find out 300 minus 225 equal to 75. So from this memory wastage calculation, we got least memory wastage for memory block 4, is it? So this is the best location or best memory block which is able to store P2 process. So P2 is allocated to block 4. Okay. Then P3 process, for allocating P3, the size 179 KB. From starting onwards, we need to check. 150 KB is not enough. Then next block 350 KB is enough to store. So 350 KB, from that block, we need to find out the memory wastage. 350 minus 179 equal to 171. Then 600 KB is the next block which is enough to occupy P3. So here we need to find out the memory wastage. 600 minus 179 equal to 421. Then the next block 250 KB, which is already allocated P2. So it is not a free space. 450 KB already allocated P1, which is not a free space. So 300 KB, which is enough to store memory block P3 or process P3. So we find out the memory wastage. 300 minus 179 equal to 121. So this is the best location to allocate P3 process. So block 6 is the suitable location for to allocate P3 process. So then P4 process 409 KB. From starting onwards we need to search. 150 KB is not enough to store P4. 350 KB is not enough to store P4. Then 600 KB is enough to store P4. So we need to find out the memory wastage. 600 minus 409 equal to 191. Then the next block which is not free, already allocated P2. The next location which is not free, which is already allocated P1. 300 KB is the last block which is already allocated P3. So only one location, block 3, is able to store P4 process. So here which is selected the best location for to allocate P4. So block 3 which is allocated P4 is allocated inside the block 3. Okay. So after the best fit allocation, we got the result like the first two blocks are not able to assign any process. So the next four blocks is block 3, 4, 5, and 6, which is allocated. Block 3 is allocated P4, then allocated P2, block 5 is allocated P1, block 6 is allocated P3. So best fit means which is able to store whatever the best location or the least wastage of memory location that will be selected to allocate a particular process. Okay, this is one example for first fit and a best fit allocation strategy. Okay.